Hello. So today we're going to be talking about another way of writing the formula for a sequence. And we're going to start by reviewing the first way that we talked about to write a sequence like 2, 5, 8, 11, 14, 17, and so on. So we said last time that we could write a formula that for the sequence that is equal to a sub n is equal to the first term, which is 2, plus n minus 1 times the common difference, which we can see here is 3. And when we simplify this, you get 2 plus 3n minus 3, which is equal to 3n minus 1. And so a sub n equals 3n minus 1 is an example of a formula for the sequence. Now, we actually have a special name for this type of formula. We call this an explicit formula. And an explicit formula means that we write this sequence in terms of n, meaning that you can substitute any value for n, and that will give you that term. So if n is 5, that will give you the 5th term. If n is 20, that will get you the 20th term. And so we see here that an explicit formula has one equation. In this case, a sub n is equal to 3n minus 1. Now, there's a different kind of formula that we can write, and this formula is more natural for a lot of kids, because a lot of students will look at the sequence and say, oh, you add 3, meaning that whatever number to find the next number, you just add 3 to the previous number. And so this idea of adding 3 to the previous number to get the next number is another way of writing the sequence. But in order to express that, you also need one other piece of information, which is what is the starting point? What number are you going to start with first? And so this is an example of what we call a recursive formula. Now, in a recursive formula, you express the nth term of a sequence in terms of the previous numbers, which means that in order for you to say what the nth term is, you have to say how it relates to previous numbers. And so recursive formulas always have more than one equation, because there's no way for you to express recursively this idea of starting from this number, do something else. There's no way that you can put it in one equation. In fact, in this case, we have to have 2 equations. The first equation is that a sub 1 equals 2, because that is our starting point. And the next equation that we have to say is that a sub n is equal to 3 plus a sub n minus 1, meaning that you take you start at 2. Now, this is what this means. This number means this equation here means you start at 2. And then this equation here means add 3 to the previous term or number. Now, there's an important difference that you need to know in this example, which highlights a very important point about notation for these sequences. If you look at these 2 sequences carefully, you'll notice that there's a slight difference between them. So take a minute and look at the 2 sets of formulas here. Pause if you need to. And see, what's the difference? Did you see it? Well, if you look carefully, you'll see that here, this means to find the nth term, you multiply the previous term by 2. This actually makes no sense, because basically what you're saying in the first one is that to find the nth term, you take the nth term and you multiply it by 2. Well, what's the nth term? It's the number that you get when you multiply it by 2. Well, what's it? It's the nth term. What's the nth term? It's the number that you get when you multiply the nth term by 2. What's the, I mean, you're going in circles. First formula makes no sense. So make sure that if you're talking about a sub n minus 1, the n minus first term, that you actually put n minus 1 in the subscript. You don't write it, you don't write the minus 1 kind of hanging outside the subscript. So let's take a look at this example. You need to find the first 5 terms of this sequence. Now, when you're writing a recursive sequence and you're given the first term, well, that counts as the first term. So the first term here, a sub 1 is 7. Now, if you look at this, this basically means you, so this equation means you start at 7. And then what you do is you multiply by 3 and subtract 12. So I like to write this out in my head at least. If you want to write it on paper, that's also fine. But at least write it out in your head so that you understand what we're doing. Now, the next term after a sub 1 is a sub 2. Now, to find a sub 2, we're going to multiply what by 3? The previous number. So the previous number was 7. And then we subtract 12. So 3 times 7 minus 12 is 21 minus 12, which is 9. Now to find the third term, you take 3 times the previous number, right? And the previous term is 9. And then you subtract 12. Now, so this is 3 times 9 is 27. 27 minus 12 is 13. And then a sub 4 is 3 times 13 minus 12, which is 39 minus 12, which is 27. And I think I made a mistake. Because actually I was just looking at this and I realized 3 times 9 is 27. 27 minus 12 is actually not 13, but 15. But now you see a problem. You see a problem because once I make a mistake when I'm calculating a sequence recursively, if I carry that mistake through, every other term I get after that will be wrong. Now, the good thing is that I am showing my work so that if this were a free response question, as long as I show all of my work, I can get partial credit. And in this case, I might lose 1 point for making that arithmetic mistake. But if I carry it through, I can get credit for the rest of the problem. Now, let's fix this to make this correct. That's 15. And then this is 45 minus 12, which is 33. So a sub 5 is 3 times 33. Minus 12, which is 99 minus 12, which is 87. So the first 5 terms are 7, 9, 15, 33, 87. And make sure that you show all of your work for these problems. Now let's write a recursive formula for these sequences. Now these sequences are quite tricky because it's not immediately clear what's happening. The numbers are decreasing. Is it arithmetic? Is it geometric? It doesn't look arithmetic because 25 minus 10 is 15 and 10 minus 4 is 6. So that's, well, actually we should be subtracting backwards, right? Because to get the common difference, that's what you're doing. So it's not the same, adding or subtracting by the same number. Dividing, well, let's see. 4 divided by 10 is 2/5 or 0.4. 10 divided by 25 is actually 2/5, which is 0.4. 5.25 divided by 62.5. Use a calculator to check. That also works out to be 2/5 or 0.4. So this is geometric because there is a common ratio. The common ratio is 2/5 or 0.4. So we express this recursively as follows. The first term is 62.5. The nth term is 0.4 times the previous term. And so both of these very important that you include both of these expressions together, because usually if you are missing one of the equations, you will lose a point for that, and because it's not fully correct. Now here we see, does this look like a common difference? And so here, a sub 1 is 90, and then a sub n is equal to the previous term, which is a sub n minus 1 minus 27. And be very careful about how you type or write this to make it clear what's in the subscript, in this case n minus 1, and what's not in the subscript. In this case, minus 27 is not in the subscript. Now, here's a tricky one. Write a recursive formula for each of the following sequences. So if a sub n equals 6n plus 3, that's an explicit formula, which means that I can calculate any of the terms by substituting the appropriate value for n. And so in order to write a recursive formula, we need to figure out the pattern. So let's look for the pattern. And we look for the pattern by writing out the numbers. Don't guess. Look at the numbers that come out of the sequence. So we'll start with the first number, a sub 1. That's 6 times 1, which is n, plus 3, and that's 9. So a sub 2, 6 times 2 plus 3, and that's 15. A sub 3 is 6 times 3 plus 3. 4 equals 6 times 4 plus 3, which is 27. And maybe by now we see a pattern. We see that the sequence has a common difference between terms of 6, not positive 6 when you subtract. And so we could see that a sub 1 is 9, and a sub 2 is the, a sub n for the recursive sequence is the previous number plus 6. So we get 9, and 9 plus 6 is 15, 15 plus 6 is 21, 21 plus 6 is 27, and so on. Now for number 12, these are particularly tricky, because if a sub 1 is 120, and then a sub n is 0.8 times a sub n minus 1, what that means is that we are basically multiplying each of the numbers in the sequence by 0.8. So the numbers should be getting smaller. So a sub 2 is 0.8 times 120, which is 96. A sub 3 is 0.8 times 96. And actually, every number after that is going to be multiplied by 0.8 times the previous number. So we can say is that this is a sub n is equal to a sub 1, which is 120 times r, which is 0.8 to the n minus 1 pound. For the last question here, this last question is really tricky because there are variables, not really numbers here, but we can follow the same rules. So the first term here is a sub 0, not a sub 1. And sometimes we start with a sub 0 instead of a sub 1. Now the nth term is going to be the previous term plus 2. So a sub 1 is going to be the previous term, which is a sub 0 plus 2. And so that's x plus 2. Now a sub 2, sorry, is equal to previous term plus 2, that's x plus 4. So a sub n minus 1 plus 2 is going to be x plus 4 and so we see a pattern here that this is going to be a sub n equal to a sub 1 plus 2 well, let's use the formula for the arithmetic sequence here. So a sub 1 is, well, a sub 0, I guess, which is x plus so here the first term is a sub 0, which is x, and then we're multiplying by n minus 1 times the common difference, and we can see here that the common difference is 2, because when we go upwards in the sequence, we are adding 2, so the common difference is positive 2. And so this is a sub n. And so this is going to be x plus 2n minus 2. And so our explicit formula explicit formula is a sub n equals x plus 2n minus 2. Now for this last question, it's very tricky because there are lots of variables and we don't really know how to handle equations like this. But we recognize that we're looking at a formula for a sub n. And so that means that n is the variable. So x we can treat like a number here, while n is the variable. So a sub 1 is equal to x squared plus 1 times x minus x. Because here, this is when n equals 1. So when n equals 2, we're going to get a sub 2 equals x squared plus 2 times x minus x, which is x squared plus x when we write it in standard form. So when n equals 3, a sub 3 equals simplify this, x squared plus 1x minus x is x squared. Now here, we're going to do a sub 3 is x squared plus 3x minus x. So that's x squared plus 2x. So we can see that we can write a recursive formula by finding the first term, which is a sub 1 equals x squared. And then the pattern, we're basically taking the previous number and adding x to it.